Yes, so we are going to start unit number 1, that's differential equation, and whose basics we started in 12th. Now little advanced sums we have to work on. Hello Shreya. And we'll start with the first part, that's basic part, and that is order and degree of the differential equation. Differential equation, okay? So let us go for that. I will explain some of the basic stuff and then you can write. We'll be starting unit number 1, differential equation. Hope the upper part of the board is visible. And now we'll start type number 1, and type 1 is type 1 is order and degree of differential equation. Type 1 is order and degree. And you know what do you mean by order and what do you mean by degree. Just write in your notebook. Write in your notebook differential equations. Type number 1, order and degree. And let us define what's order and what's degree. And we'll conclude this basic stuff today. Okay, what's order and what's degree. This is important now. Yes, order and degree. Just check 1 mark question. So write in your notebook differential equations. Type number 1. Order and degree now. So what do you mean by order? Order means it is the order of derivative. That means number of derivatives taken, maximum number of derivatives taken in the differential equation. That means what? It is the order of highest derivative occurring in differential equation. I repeat, it is the order of highest derivative occurring in the differential equation. So if you remember, it is the order of highest order derivative occurring in differential equation. So remember, it is order of highest derivative occurring in differential equation. So can I say this is highest number of derivatives taken, highest number of derivatives taken in a differential equation, that is called as order. Order means total number of maximum derivatives taken. Sometimes 2, sometimes 3 derivatives taken, d cube y by dx cube. Then that becomes what? Order. And what is degree? It is power or index of highest ordered derivative. I repeat, it is power or index of highest ordered derivative. I repeat, it is power or index of highest ordered derivative. Then it is called as what? Degree. Remember. So write first order. It is the order of the highest derivative occurring in differential equation. That means highest number of derivatives taken. And then write it is power or index of highest ordered derivative. I want you to write some more after this, but first write this one, then I will explain what is the next step we want. Yeah, write this quickly, and once done, please let me know. Write this quickly, once done, please let me know. Yes, and now I want you to extend one statement here. I want you all to extend one more statement here, like it is the power or index of highest order derivative. I repeat, it is power or index of highest order derivative taken, highest order derivative taken, provided that the differential equation must be free from roots, oblique radicals, oblique negative powers, oblique fractions. Roots, that means radicals, negative powers, fractions. If any differential equation is free from these all things, that means roots, that means radicals, that means negative powers or fractions, then only we can write order and degree. For example, just check, I will give you example and you will come to know what's order and degree. If I have it like this, d cube y by dx cube raised to 4 is equal to 0. Tell me what is order? Tell me maximum number of derivatives taken. What do you find order as? Yes, maximum number of derivatives taken 3, correct. So order is going to be 3. So remember here order is going to be what? 3. And what is degree here? 4. Why? Degree is power of order. First you need to find order and then you have to find what? Degree. So remember order and degree. Order 3, degree 4. Remember this one, order 3 and degree 4, and that is what order and degree of the differential equation. Order means number of derivative, number of maximum derivatives taken in the sum, and degree means its power. Okay, now I will give 4 to 5 examples, not more than that, because this is quite easy topic. I repeat, this is quite easy topic, so I'm going for only 4 to 5 examples, and then we'll start the actual lesson, because lesson starts with differential equations. Order and degree is the basic part. Okay, order and degree is the basic part we have. Yes, question number 1. So we'll start with question number 1. Concentrate now. We want order and degree of this. Question number 1, that is d square y by dx square bracket cube plus dy by dx bracket raised to 4 plus y is equal to 0. Tell me quickly what is order and what is degree. Tell me quickly what's order and what's degree. Do you find highest ordered term here? Yes, tell me what's order and what's degree. Yes, order 2, degree 3, correct. Order 2 and degree 3. Why? This is the highest order derivative. This is not possible. This is single derivative. This is double, and double is the highest one. So order 2, degree 3, that's correct. We'll go for one more example. Don't write. I will give you time to write. Okay, check next example. Next example is number 2. 1 plus dy by dx bracket square raised to 3 by 2 is equal to rho into d square y by dx square. Rho into d square y by dx square. Now check this. Can we write direct order and degree here? Yes, tell me. Can we write direct order and degree here? Can we write direct order and degree here? No, you cannot write direct order and degree. Read definition. Read definition. Differential equation must be free from roots, radicals, fractional powers, negative powers. Just check. This is fraction. We cannot write order and degree. How to remove this fraction? Squaring both sides. This is 3 by 2, na? That means root includes. So we have to square both sides. So squaring both sides, just check what I'm going to get. Squaring both sides. Check this one. Squaring both sides. If I take square on both sides, check what I'm going to get. If I take square on both sides, this will be 1 plus dy by dx bracket square raised to 3 is equal to rho square d square y by dx square bracket square. Why? I'm taking squares on both sides. And now check and tell me what is order and what is degree. Now we will get answer of this one. Tell me what's order. This is order 1. Why? Only one derivative taken, 2 derivatives taken. So this is the term order 2 and its power degree 2. Everybody understood this? Everybody understood this? Don't write. I'm going to explain 2 more examples. Don't write. Yes, hope everybody understood this one. Chalo, next, number 3. Check number 3. Number 3 is dy by dx plus k is equal to 1. Sorry, plus k upon dy by dx is equal to 1. Tell me how to start this. Tell me how to start this. Yeah, tell me how to start this. Yes, can we write direct order and degree? Can we write direct order and degree of this one? Can we write direct order and degree of this one? No. Yeah, multiply by dy by dx. So if I multiply by dy by dx throughout, check what I'm going to get. I'm going to get dy by dx into dy by dx will be dy by dx square. Don't write double derivative. Don't write double derivative. That becomes a square. Plus k is equal to 1 into dy by dx, dy by dx. Now this is order 1, this is order 1, but the power is 2 here. Na? So what's the answer? Order and degree. Tell me what's the answer? Order 1, degree 2. Highest term is here, whose power is 2. Correct? Yes, check next. Next check and most important. Number 4, which is dy by dx plus integration of y dx is equal to x. My first question is whether is this differential equation or not. My first question is whether this is differential equation or not. Is this a differential equation? Tell me whether this is differential equation or not. Yes, whether this is differential equation or not. No, this is not differential equation. Can you justify why this is not a differential equation right now? Can you justify why this is not a differential equation right now? Why this is not a differential equation right now? Yes, tell me quickly. Integration, correct. Since there is integration, we cannot say this is differential equation, correct. Now, how to remove this integration? How to remove this integration? How to remove this integration? Differentiate. If you differentiate, integration will be removed because integration is anti-derivative. Na? So I'll say this one as, just check. I'll say this one as, yes, I'll say this one as differentiating with respect to x. So this will be double derivative, d square y by dx square plus integration will be cancelled, only y left, derivative of x will be 1. Why? I'm differentiating both sides. If I'm differentiating both sides, I repeat, if I'm differentiating both sides, this will be double derivative, integration cancelled, only y left, derivative of x is 1. And now order and degree is, order is 2 and whose power is, what is power of this? Power of this is 1, therefore degree is 1. Yeah. Everybody understood this fourth one? Let us move to the next example then. Yes, number 5. Check number 5. Number 5 is cube root of d square y by dx square is equal to square root of dy by dx. Cube root of this is equal to square root of this. And now you will tell me, yes, tell me how to start this. Can we write direct order and degree or we have to do something else? Yeah, I will rewrite this. Just check. Not cube. Check this. I will rewrite. This is d square, na? So can I write d square y by dx square raised to 1 by 3 is equal to dy by dx raised to 1 by 2? And now tell me, that's what the important part. Can we take cube? No, cube is not possible. We have to take LCM of 3 and 2 and that is 6. So taking 6th power, okay. So I can write like this, taking 6th power. If I take 6th power, it will be d square y by dx square raised to 6 by 3 is 2. dy by dx raised to 6 by 2 is 3. But still, this is highest order. Why? This is order 2, this is order 1. So order 2 and degree 2. Everybody understood this? Everybody understood this? Yes. Now tell me, last example, what we have to do in last 6th example. Tell me what we have to do in 6th example. Tell me what we need to do in 6th example. Type number 2. This is all about formation of differential equation. Remember, this is going to be formation of differential equation. Most important part. Formation of differential equation. Check how these differential equations are formed. We are going to form differential equations and one important rule I want you all to listen to me. Yes, माझा आवाज ऐकू येतो ना सगळ्यांना? Visible आहे ना screen? येस, मला लक्षात येत नाही. ओके ओके येस, चलो. फॉर्मेशन ऑफ डिफरेंशियल इक्वेशन. सो व्हाट इज नोट? द मोस्ट इंपॉर्टंट नोट वी हैव इज number of arbitrary constants. Most important, number of arbitrary constants is equal to number of differentiations, means number of derivatives taken, is equal to order of differential equations. Right? Yes, chalo. So, number of arbitrary constants is equal to number of differentiations is equal to order of differential equation. म्हणजे काय? जेवढे arbitrary constants तेवढे derivatives घ्यायचे. The number of arbitrary constants is equal to number of derivatives taken is equal to order of differential equation. So, जेवढे arbitrary constants तेवढे derivative घ्या आणि तेवढेच ऑर्डर असेल त्याची. म्हणजे काय? बिफोर दॅट तुम्हाला माहितीये का arbitrary constants म्हणजे काय? येस, तुम्हाला माहितीये का बेसिक? डू यू नो दिस बेसिक? दोन प्रकारचे कॉन्स्टंट असतात, हे माहित पाहिजे. तुम्हाला लक्षात ठेवा, हे कुणी विचारले याच्या पुढे तर माहित पाहिजे. तुम्ही तर इंजिनिअरिंगला आहे. कॉन्स्टंट्स, दोन प्रकारचे कॉन्स्टंट्स असतात. एक म्हणजे फिक्स्ड कॉन्स्टंट आणि एक म्हणजे आर्बिट्ररी कॉन्स्टंट्स. एक म्हणजे फिक्स्ड कॉन्स्टंट आणि एक म्हणजे आर्बिट्ररी कॉन्स्टंट्स. फिक्स म्हणजे कुठले आणि आर्बिट्ररी कुठले हे लक्षात घ्या. चेक दिस. माझ्याकडे एक असं इक्वेशन आहे. इफ यू रिमेंबर दिस, आहे का माहित तुम्हाला इक्वेशन? रे हा कुठलं इक्वेशन आहे सांगा. आहे कॅन यू टेल मी विच इक्वेशन इज दिस? येस, सांगू शकता कुठलं इक्वेशन आहे? सर्कलचं इक्वेशन आहे. या तीन कॉन्स्टंट्स आहेत बघा. या तीन कॉन्स्टंट्स आहेत एच, के आणि आर. एक्स आणि वाय ही व्हेरिएबल्स आहेत. आता मला सांगा, सेंटर रेडियस फॉर, मला सांगा एच, के आणि आर यामधला कोणता फिक्स कॉन्स्टंट आहे आणि कोणता आर्बिट्ररी कॉन्स्टंट आहे सांगा. विच वन इज फिक्स्ड अँड विच वन इज आर्बिट्ररी आउट ऑफ दीज इक्वेशन? एच, के आणि आर तीन कॉन्स्टंट्स, यापैकी कोणते फिक्स्ड, कोणते आर्बिट्ररी? आर कोणता आहे? आर इज फिक्स्ड. करेक्ट, आर इज फिक्स्ड. व्हेरी गुड. हा फिक्स्ड आहे, हा फिक्स्ड आहे. करेक्ट. आणि हे दोन आर्बिट्ररी आहेत. लक्षात घ्या, हा फिक्स्ड आहे आणि हे दोन आर्बिट्ररी. म्हणजे काय? तर आर्बिट्ररी म्हणजे चेंज होत राहणार आहेत आणि फिक्स म्हणजे काय? जो फिक्स असणार आहे, ज्याचे कॉन्स्टंटची व्हॅल्यू चेंज होत नाही. फॉर एक्झाम्पल, एखादं सर्कल घेतलं मी 4 रेडियसचं. रेडियस ऑफ सर्कल इज 4. आता सर्कलची रेडियस 4 असलेलं सर्कल तुम्ही क्वाड्रंट मध्ये कुठल्याही ठेवा, रेडियस बदलत नाही. पण क्वाड्रंट बदलल्यावर त्याच्या सेंटरचे कोऑर्डिनेट्स बदलतात. अँड दॅट इज व्हॉट आर्बिट्ररी. आर्बिट्ररी मीन्स whose values are changing and fixed means whose value doesn't change. Remember this. And that is what arbitrary and fixed. सगळ्यांना constant म्हणजे कळलंय arbitrary and fixed. Yes, everybody understood what is arbitrary and what is fixed. Yes, everybody understood what's arbitrary and what's fixed. Yes, पटकन हे लिहून घ्या. फॉर्मेशन ऑफ डिफरन्शियल इक्वेशन. पटकन हा टायटल लिहा, नोट लिहा, then we'll go for examples. Whose general solution is? Yes, so तुम्हाला तर जनरल सोल्युशन दिलं असेल आणि तुम्हाला डिफरन्शियल इक्वेशन काढायचंय. त्यासाठी तुम्हाला आधी आर्बिट्ररी कॉन्स्टंट्स किती आहे ते बघावे लागतील. जेवढे आर्बिट्ररी कॉन्स्टंट्स तेवढे डेरिव्हेटिव्ह घ्यावे लागतील. सो लेट अस स्टार्ट विथ एक्झाम्पल नंबर 1. फक्त लक्ष द्यायचं, लिहिण्याची घाई नको. क्वेश्चन नंबर 1. फर्स्ट काय बघा, y इज इक्वल टू a e raised to minus 90 into cos of 3t plus b असं तुम्हाला दिलंय. मला सांगा यात आधी व्हेरिएबल कोण आहे आणि मग कॉन्स्टंट सांगा. मला सांगा यात आधी व्हेरिएबल कोण आहे? टी व्हेरिएबल आहे. कॉन्स्टंट्स कोणते आहेत सांगा. हा, विच आर कॉन्स्टंट्स हियर? येस, विच आर कॉन्स्टंट्स हियर? A and B constants. So there are two constants. There are two constants. If there are two constants, we have to take two derivatives. जर दोन कॉन्स्टंट्स असतील तर दोन डेरिव्हेटिव्ह घ्यायचे. जेवढे डेरिव्हेटिव्ह घेऊ तेवढे ऑर्डर येईल. ऑर्डर 2 येणार आहे. सो आपल्याला दोन डेरिव्हेटिव्ह घ्यायचे. करेक्ट, समजतंय सगळ्यांना? सो आय विल गो फॉर डिफरन्शिएटिंग दिस ट्वाइस. याला मी दोनदा डेरिव्हेटिव्ह घेणार आहे. आता समजा मी याचा डेरिव्हेटिव्ह डायरेक्ट घेतला तर हे टीचं फंक्शन आहे, हे पण टीचं फंक्शन आहे, म्हणजे युव्ही रूल होईल. मी अवॉइड करू शकतो युव्ही रूल. कसा? पहा, I will avoid this UV rule. Check how I'm going to avoid this. Can I write like this? Y into e raised to plus 90 is equal to a into cos of 3t plus b. आणि याला मी नंबर 1 म्हणतो. समजलं सगळ्यांना? मी हे e raised to minus 90 इकडे आणलं आणि प्लस केलं. आता राईट साईडला UV रूल होणार नाही, लेफ्ट हँड साईडला होईल, पण ते इझी आहे म्हणून याला इकडे आणलं. समजतंय सगळ्यांना? So we got it like this. I got this as number 1. How many times derivative allowed? 2 times because there are 2 constants. So let us go for this. Differentiating with respect to t. काय मिळतंय बघा? UV rule. Y derivative e raised to 90 is e raised to 90 into 9 plus e raised to 90 derivative y is y1. पहिला डेरिव्हेटिव्ह घेतला मी. u derivative v plus v derivative u is equal to a. तसाच derivative cos is minus sin of 3t plus b into derivative 3t is 3. चेन रूल. सो पहिला डेरिव्हेटिव्ह घेतला मी. आय डिड फर्स्ट डेरिव्हेटिव्ह. अगेन डिफरन्शिएटिंग. अजून एकदा अलाउड आहे कारण टोटल 2 घ्यायचे. सो अगेन डिफरन्शिएटिंग विथ रिस्पेक्ट टू टी. मी अजून एकदा डेरिव्हेटिव्ह घेतोय. पहा काय मिळणार आहे. सो हे 9 मी बाहेर घेतो आणि ब्रॅकेट मध्ये सगळं करणार आहे युव्ही रूल परत. y डेरिव्हेटिव्ह e raised to 90 e raised to 90 into 9 प्लस e raised to 90 into derivative y is y1. कळतंय सगळ्यांना? मी काय केलं तर मी हा 9 बाहेर घेतला आणि याला युव्ही रूल अप्लाय केला. प्लस याला परत युव्ही रूल. काय बघा? e raised to 90 into derivative y1 is y2 प्लस y1 तसंच u derivative v plus v derivative u e raised to 90 चा e raised to 90 into 9 is equal to. करेक्ट? इज इक्वल टू. मी काय घेतोय तर मी डायरेक्ट डेरिव्हेटिव्ह घेतोय. युव्ही रूल अप्लाय केले. आता बघा इज इक्वल टू हा ए मायनस तसंच ए तसंच. करेक्ट? साइनचा डेरिव्हेटिव्ह कॉस ऑफ 3t प्लस बी इंटू डेरिव्हेटिव्ह 3t इज 3 आणि हा 3 हे 9 झालं. करेक्ट? आता नीट बघा यातून मी e raised to 90 कॉमन घेतो कारण e raised to 90 प्रत्येक टर्म मध्ये आहे. सो e raised to 90 जर मी कॉमन घेतलं तर उरेल काय बघा? 9 9 जार 81y. 9 into y1 is 9y1 plus y2. करेक्ट? प्लस 9y1. करेक्ट? मी e raised to 90 कॉमन घेतलंय. इज इक्वल टू मायनस 9 इंटू तुमच्या लक्षात आलं असेल तर ही टर्म इथं आहे बघा. करेक्ट? ही टर्म इथं आहे बघा. म्हणजे याच्याऐवजी y e raised to 90 लिहिता येईल. सो आय जस्ट राईट y e raised to 90. आणि तुम्हाला दोन्हीकडे बघितल्यावर लक्षात येईल हे e raised to 90 दोन्हीकडून कॅन्सल होतं. म्हणजे आता उरलं काय बघा? फायनल टर्म इज y2 प्लस 9y1 9y1 18y1 प्लस 81y मायनस 9y प्लस 9y म्हणजे 90y is equal to 0 and this is your final answer. This is your final answer. हे डिफरन्शियल इक्वेशन मिळालं. y2 म्हणजे डबल डेरिव्हेटिव्ह याचा अर्थ ऑर्डर 2 आणि त्याची पॉवर 1 म्हणजे डिग्री 1. दॅट्स द आन्सर. समजतंय सगळ्यांना? येस, एव्हरीबडी अंडरस्टूड दिस फर्स्ट प्रॉब्लेम? येस. दिस इज UV रूल. दिस 9 आउटसाइड, दिस इज u, दिस इज v. u डेरिव्हेटिव्ह v plus v derivative of u. Same here, u and v. u derivative of v plus v derivative of u. This a as it is. Sin derivative is cos. 3t is 3 and 3 9. Now e raised to 90 is taken outside. What left inside is 9 9s are 81, 9y1, y2, 9y1. This original term is here. Y e raised to 90. Now you can cancel e raised to 90. What we have is y2, 9y1 plus 9y1, 18y1 plus 81y plus 9y, which will be 90y. Got it, Ketan? Yes, next question now and check next question. Next question is y is equal to number 2. Number 2, y is equal to log of cos of x minus a plus b. Log of cos of x minus a plus b. Check this carefully now. I will start with this differential equation, the equation, and we'll go for differentiation. Tell me how many constants you find here. Tell me how many constants you find here. This is number 1. Yes, 2 constants, a and b. So we have to differentiate twice, correct? We have to differentiate twice. So differentiating with respect to x. Derivative of y will be dy by dx. Instead of dy by dx, you can write y1. Doesn't matter. You can write y dash also. Okay. So dy by dx. Derivative of log is 1 upon cos of x minus a into derivative of cos is minus sin of x minus a plus derivative of b is 0. This is chain rule. Log of cos is 1 upon cos. Derivative of cos is minus sin. Now finally this becomes dy by dx is equal to minus sin upon cos is tan of x minus a, I will call this as number 2. Correct? Check this now. So I have it like this. Differentiating with respect to x we got, but how many derivatives allowed? 2. And I did only 1. So again differentiating. So again differentiating with respect to x. This becomes d square y by dx square, because double derivative. Derivative of tan is sec squared of x minus a. We did 2 derivatives. But remember, in final answer, we don't want a or b because these are arbitrary constants, so we have to remove them. Still a there. Check the adjustment now. Can I write minus sec squared as 1 plus tan squared of x minus a? And can I use this tan here? How? Squaring both sides. If I take square of this, minus square is plus. This will be tan square. Square of this. So instead of this, can I write like this? Minus 1 plus square of this dy by dx bracket square. And finally, double derivative is equal to, will be plus 1 plus dy by dx bracket square is equal to 0. This is the answer. Order is 2 and degree is 1. Everybody understood this? Everybody understood this? This adjustment is done here. Because we want final answer free from constants. Here, don't write. I will explain one more example, then you can write. I will explain one more example and then you can write. Don't write. Yes, example number 3. Example number 3 is y is equal to c square plus c upon x. Yes, c square plus c upon x. Tell me how many constants you find here. Tell me how many constants you find here. Yes, only one. See, only once differentiation allowed. Correct. Only one constant, that means differentiation allowed only once. Check how. So I'll go for rewrite this. Y is equal to c squared plus c upon x. Number 1. Differentiating with respect to x. Dy by dx is derivative of c square is 0 because that's a constant. C as it is, derivative of 1 upon x is minus 1 upon x square. From this, I will find c. C will be shifting it here minus. So it will be minus x square dy by dx. I will put this value of c here. So 1 becomes. I am going to back substitute the value. Why? C square means square of this, na? X raised to 4 plus dy by dx bracket square. Why? It's bracket square here. Plus c. C is minus x square dy by dx upon x. I'm just putting value of c. X cancelled. So we got it. Y is equal to x raised to 4 dy by dx bracket square minus x dy by dx, and that's the final answer without arbitrary constants. Order 1 and degree 2. Everybody understood these both examples? Yes, let us move now 4th example and the important one. Tell me how many constants you find in 4th one. Tell me how many constants you find in 4th one. How many constants you find in 4th one? 2 constants. That means differentiation twice. Correct? Differentiation twice. Check how. So I'll go for this like this. Y is equal to a cos of log x plus b sin of log x. I will call this as number 1. Differentiating with respect to x. So it will be y1. A as it is, derivative of cos is minus sin of log x into derivative of log x is 1 upon x, plus b sin of will be cos of log x because derivative of sin is cos, derivative of log x is 1 upon x. Bring this x behind, so it will be xy1, shifting this x here, is equal to minus a sin of log x plus b cos of log x, and I just did first derivative. Differentiating this once, shifting this x on the left side. Again differentiate because 2 derivatives because two constants. So two derivatives now. So second, again differentiating with respect to x, UV rule, x derivative of y1 is y2 plus y1 derivative of x is 1 minus a as it is. This is u derivative v plus v derivative of u. A sine derivative is cos of log x into derivative of log x is 1 upon x. B as it is, derivative of cos is minus sine of log x into derivative of log x is 1 upon x. I'm just shifting this x to the left side and it becomes x squared y2 plus xy1. Shifting this x behind, that is to the left hand side. So it will be x squared y2 plus xy1 is equal to minus common. We have a cos of log x, correct, plus b sine of log x, since we have taken minus sign outside, and now this is here, which is y, and this is here, which is y, and I will rewrite x squared y2 plus xy1 is equal to minus, this is going to be y, this is going to be y, minus y on left hand side will be plus y. So your final answer I'm going to write, final answer is x squared y2 plus xy1 plus y is equal to 0, and this is your final answer having order 2 whose power degree is 1. Everybody understood this? Yes. So thank you very much. Hope you understood today's concepts. We'll meet in the next class, that means tomorrow. Yes. Thank you. Thank you very much and have a great day ahead. Thank you all.